So hello all, Electro this side. So today's problem is Subarray sums equals k. So let's quickly read the problem. Given an array of integer nums and an integer k, return the total number of subarrays whose sum equals to k. A subarray is contiguous non-empty sequence of elements. So the problem is pretty much simple. We have been given an array of integers. Let's take this one 111, and this one 111, and there will be k, this is 2 in this case, and we need to return the count of all subarrays, the count of subarrays whose sum is equals to 2. For example, in this subarray, okay, this subarray has a sum 2, this subarray has a sum 2, so the count of subarray will be 2. Let's take this example 1 2 3. Another is 1 2 3. In this case, again k is equals to 3. So subarray whose size is 3 is 1 2 3 itself. So again, in this case, count is also equals to 2. So if you don't know what subarray, a subarray is basically any contiguous part of array. Any contiguous section of array is called a subarray. For example, let's say 1 2 6 4 2 9. Let's see, this is the array. 1 is a subarray in itself. It is a contiguous part of the array. 1 2 also is a subarray. 2 6 4 is also a subarray. What's not a subarray is 6 2 5. If I take 6 to 5, then it is not a subarray. It will be called a subsequence. This is the basic terminology that you need to understand about subarrays. Let's try to understand the problem. So the very basic solution, the very brute force solution that first came when I was 9 is generate all the subarrays, and while generating all the subarrays, do sum of each subarrays, and if the sum of that subarray equals to k, then increase the counter. So let's try and with some example. Let's say 1 3 4 2 2. Let's say this is the array, and we have k equals to 4. Okay, how can we generate all subarray? Okay, let's start with subarray starting with 1. First 1. Sum is 1, then 1 3. Sum is 4 4. K equals to 4, so count becomes 1. Okay, then again 1 3 4. Since it has now increased, since 1 3 4 1 4 8 8 10 12. So in this case, so the subarray starting from all the subarrays starting with 1, only 1 3 is the subarray whose sum is 4. Let's do that for similarly. If you do that for subarray starting with 3, subarray starting with 4, subarray starting with 2, subarray starting with 2, you will get the count of, you will get a count of 3. Like this is the subarray whose sum is 4, this is 4, and this is 4. So in this case the count of subarray will be 3. Another thing, the main thing that we need to consider in this problem are the constraints. So the constraints are the length of the input would be up to 10 to the power 4, and the numbers can be negative, and the sum of the subarray that is required can also be negative, since the numbers can be negative. So in this case, let's think about this. In this case, why? So in this case, one thing that can come in your mind, that if I have got a Subarray sum equals to 4, then why I am doing, so why I am expanding the Subarray more, why I am expanding the Subarray more, if I already know that if I 4 is achieved, then adding the element will always increase the sum. This is why, because this, the numbers can be negative. Let's say it becomes minus 4 here. In that case, this one will also give a sum of 4. Okay. So in that case, from all the Subarrays that are starting from 1, there will be, from all the Subarrays that are starting from 1, there will be 2. There will be 2 Subarrays whose sum equals to 4. So that's why we are not going with that, because the numbers can be negative also. So that is the brute force solution. The expected time complexity of that will be order of n square, and the expected space complexity will be order of 1. For that, I can say it will be an in-place algorithm. So let's talk about the main thing on this problem. That is how to solve it optimally. That is something we need to learn. How to solve this problem optimally. So the optimal solution is basically using the concept of prefix sum. How we can solve it using some sort of prefix sum? Let's try 1, 3. Let's give the same example, 1 minus 2, 2, and 2. And the sum that is required is 4. What is the concept of prefix sum? Prefix sum at particular index is equals to basically sum of all the elements, is equal to sum of all the elements. In that case, 1, 3, 4, 4 minus 1, 0, 2. The prefix sum of this equation will be 2. Correct. We want k equals to 4. Is ending at, if I can think about it, ending at 2, the Subarrays that will be ending at 2 and have sum equals to 4. How can I count them? Okay, so let's say this is the prefix sum 2. If I go back and I need to basically check, if I reduce k from the prefix sum, let's say it comes here. If I reduce k from the prefix sum, how many times, if I reduce k from the prefix sum, how many times that 2 minus k has occurred previously in the array? That will be the count of all the Subarrays whose sum equals to k and are ending with 2. Okay, let me explain it again. Let me explain this thing again. Okay, let's explain it again. Let's directly think it example. Okay, so the problem is, if I let's take it more generalized. Okay, let's say this is an array. Let's say you are at here. Okay, the prefix sum here is s. Now, what I can predict is, okay, I need a Subarray sum of k. I need to find Subarray sum of k. If I think about this element at the end of the Subarray, since Subarray is continuous, so if I reduce k from s minus, it will be s minus k. I just need to find how many times s minus k has previously occurred as a prefix sum in the array. That that will be the overall approach. So let's now look at the code of this problem. Okay, we initialize a counter variable. Okay, we are using a map. Okay, so we are using a map data structure here. So the map data structure basically hold unique key value pairs. So we have a key as an integer that that will denote a particular sum, that will denote a prefix sum, and integer will be how many times that particular prefix sum has occurred in the array. We put the prefix sum, we put the default value 0 and 1. See, there can be there can be there can be there can be cases when the sum of the prefix sum becomes equals to k. There can be cases the prefix sum, let's say the prefix sum here, the prefix sum is s. There can be a case when it will be equal to k. Let's think about this. Let's try to visualize this also. This is the array. Okay, you are here s. If s equals to k, that means this is also k. So in that case, s minus k equals to 0. In that case, what will be the count of subarrays? That will be 1. For that, we have this base case, I can say, base case condition in the map. Prefix sum is basically denoted the prefix sum of all the elements up to current position. So int n nums, we keep increasing this. If prefix sum contains this key, then count will be how many times it has occurred. Else the prefix sum would be, we put this prefix sum and we get the default value and increase the counter. And if I return it, let's quickly run it. It works. Let's try to submit this. Yep, accepted. So what is the time complexity of this? So the time complexity will come is basically order of n, as we are traversing down the array a single time. And the space complexity of this will be O of n, not O of n. The space complexity of this, at the worst case, the space complexity of this will also be order of n. So that's all for this video. Drop like, comment, and give feedback on this thing I can improve. Thanks all.